Good afternoon, ladies and gentlemen. I am Ankes. I am working as Senior Regional Manager North with EDrive Technologies. First and foremost, we thank each and every one of you for taking your time out and joining us for this webinar. We hope you and your family are staying safe and healthy in these troubled times. Welcome to our webinar on electric powertrain and battery development for electric vehicles. Today's agenda is introduction to EDrive Technologies Private Limited. We have ICAT-International Centre for Automotive Technology, Dassault Systèmes, key trends in automotive, opportunities for startups, OEMs, suppliers, system engineering, key enabler, Indian case studies, and summary. So I would like to begin the webinar by giving a short introduction about our company, EDrive Technologies. EDrive Technologies Private Limited was incorporated in 1994 to focus on providing PLM solutions, implementation, and support. We are the largest PLM and engineering solution provider in India and also platinum partner to Dassault Systèmes. We have served more than 1,500 customers across India. We operate in 7 locations across India with our headquarters at Bangalore. We have a strategic partnership with world leaders like US for additive manufacturing requirements, human solutions for ergonomic solutions for automotive and aerospace industries, Technia for ensuring product data quality. For military simulation and training needs of aerospace and defense industry, we have partnered with Presagis and Mac for visual simulation solutions. With respect to EDA solutions, we closely work with Synopsys. For GIS, we have partnership with ISRI. We also have recently signed up with Festo for Industry 4.0 solutions for the academia. We have a dedicated sales support, marketing, and customer satisfaction team to address customers' PLM business and support requirements. We also have our own e-learning portal, EDST e-learning, which is web-based training and skill development application with more than 135 CAD and domain-based courses where we have more than 10,000 subscribers as on date. Coming to the EV industry in particular, we have engaged with multiple EV manufacturers in India. In terms of solutions, we support them for battery engineering, body structure engineering, charging infrastructure, electric powertrain, interior and exterior trims, and electrical wiring harness. In today's webinar, we have 2 speakers. GOPAL Singh Rathore is the Deputy Manager from ICAT, who has 8 years of experience in CAE structural, CFD, and multi-body dynamics. He will be speaking on how ICAT can support EV OEMs and component manufacturers in the testing and development phase. Our second speaker is Mr. Rupesh Khopade, working as industry process consultant in Dassault Systèmes in India. He has more than 15 years of experience and is currently working with EV OEMs, startups, and suppliers to help them adopt and set up design, manufacturing, and marketing processes, which includes 1D simulation. He will share his thoughts on electric powertrain and integrated system engineering approach. We shall taking up question and answer after delivery of the webinar. We shall also be accepting queries through question box, which also will be addressed post-webinar. Hope you have an exciting and knowledgeable session. Over to you, Mr. Gopal.
Good afternoon, everyone. Thank you, Ankesh, for the brief introduction. Today I will be speaking on the subject wherein we will be discussing on about ICAT, about Aspire, also about how ICAT can support electric vehicle manufacturers and component manufacturers with respect to testing and development. International Centre for Automotive Technology is a center which is developed under NATRE project, that is National Automotive Testing and Research and Development Infrastructure Project, set up by Government of India. ICAT provides services in the domain of testing, validation, design, simulation, and homologation. The center was established in 2006 and is located in Manesar, Haryana, and is spread over 2 centers, that is Center 1 with 8 acres of space and Center 2 with 46.6 acres of space. These are the various facilities which ICAT has. We deal in different types of testing and development phases of automotive domain and also for non-automotive segments. It includes vehicle evaluation lab, chassis dynamometer lab, mileage accumulation chassis dynamometer, CAD-C lab, fatigue lab, crash lab, and various other testing centers which can be seen on the screen. Now coming to the Aspire, it's a very innovative initiative which has been taken by ICAT. It's basically an automotive solution portal for industry research and education in order to support an Atmanirbhar and Bharat Abhiyan in order to make the country a self-reliant in automotive segment. So Aspire is basically developed by ICAT under the guidance and support of Department of Heavy Industries, Government of India. And the key highlights of it includes R&D and technological innovations in the segment of product technology development, technical and quality problem resolution for the industry. We do host many grand challenges wherein anyone can participate and develop technology and even get mentored. And the key users which are currently using the Aspire portal include students, startups, industry, academia, and industry professionals also. So for more details, anyone can log on to the website given on the screen. Now, as I work on the CAD Lab, like we have been working on this development activity through virtual validation, and then we go for CAD facilities itself. This basic, what I wanted to share is it includes about the hardware facilities. It's we have a high performance computing cluster where we can run various high memory or high core intensive job requirements for simulation purposes. In the software tools, we use various commercial packages in order to support the automotive industry. These are the major focus areas, which includes electric vehicles, development of CAD, strength, durability, CFD, crash, MBD, NVH, thermal, wherein we support our customers in these various domains, right from the scratch till the product development. Now I will cover some very brief on how ICAT is supporting industry in terms of electric vehicle testing and component testing. So basically we involve vehicle level validation. Vehicle level validation basically has road load data measurement, electric vehicle measurement, and performance testing and safety. So all these aspects are basically covered during the vehicle level testing, which can be part of a certification or it can be part of a development testing. Then EMC testing, that is electromagnetic compatibility testing. So we have a completely full-fledged vehicle test chamber wherein a complete bus can be easily incorporated for the EMC test requirements at vehicle level. Then coming to component testing, various facilities includes for like battery test facilities, motor test, ECU, power electronics, and EMC. As you can see over the screen, there are various test setups which are being shown for the battery and motor. One of them you can see is a shock test facility, then vibration testing, then motor power test as per the regulations available in the automotive industry standards. These are various standards on which we provide services in the domain of testing and development. So it is divided into three segments, that is vehicle level testing, then motor, generator, electronics, and battery. There are some cases wherein customer brings up some specific DVP in order to validate their products, and we support in that also. Thank you.
Thank you, Mr. Gopal, for giving us insights on ICAT facilities. It was heartening to know such a wonderful facility which ICAT has. Now I request Mr. Rupesh Khopade to take the presentation forward for this webinar. I welcome Mr. Rupesh Khopade, please. Thank you.
Thank you, Ankesh. Thank you, Gopalji. And good afternoon, everyone, and a very warm welcome to today's webinar. I will quickly touch upon introduction to Dassault Systèmes, and then we will deep dive into today's topic. So this is the organization, Dassault Systèmes, where I belong to. And we are a purpose-driven company, and the sole objective is to combine art, science, and technology for sustainable world. We have more than 20,000 passionate people, employees who are spread across 140 nations, and put together we have around 195 offices worldwide. We have one umbrella of global R&D, which constitutes of 69 labs worldwide. In terms of revenue, Dassault Systèmes revenue spreads to 4.4 billion euros, and there is a continuous increase in the turnover, and also the operating margin is significantly good, which is of 36%. We do operate with our partners. There are more than 12,000 partners worldwide, and partners constitute to different operations, which include sales, support, education, research, as well as consulting and system integration services. So EDS is one of the leading partner for Dassault Systems here in India, and we enjoy long-standing partnership with EDS Technologies. If we talk about the customer, there are more than 270,000 customers worldwide, spread across 11 different industries in 140 countries. If we talk about the unique users, there are more than 25 million users of our solutions. And we try to bring in all our solutions on one common digital platform that is called as 3D Experience Platform. So that's the brief about Dassault Systems. So going to today's topic, I will be discussing in brief about the key trends that we observe in automotive industry. So to begin with, past more than 6-7 decades, as far as automotive industry is concerned, it has been dominated by IC engines until the recent past, wherein there are a lot of technological trends which are coming up, like hybrid vehicle and IC hybrid, which involves battery hybrid electric vehicles and others. And also the other two trends that we see, like connected cars or autonomous vehicles, right? So there are disruptors today in the market who are kind of bringing that new technology into the automotive market, and there is a strong innovation curve which is leading towards the greener products, with a lot of innovation around batteries and overall propulsion of automotive vehicles are getting more and more greener, and thanks to a lot of innovation brought by these innovators. As far as India is concerned, in past few years, maybe less than 5 years, we have seen significant number of startups coming up in these three segments. The first one is two-wheeler, the second one L5 vehicles, and the third one is electric buses. Of course, the passenger cars and commercial vehicles will follow, but at the moment, this is the trend that we see in Indian market. Okay, so it's not only the startups. We have seen a strong comeback from the existing OEM into the market, and this is just a few examples of it. Recently, few months back, Tata Nexon celebrated its first anniversary into the market. Also, Bajaj Chetak has recorded significant sales numbers, and JBM has backed a big order for supply to the Delhi Municipal Corporation, right? So it's not only the startups, but now existing OEMs are also coming to the market in a big way. So what are the opportunities in this particular market for startups, OEMs, and suppliers? So we will discuss in next session. First is the technology adoption. There is a disruption coming from all sides as far as technology is concerned, and these are the big mega trends which are changing all other industries, including automotive. The first one is IoT, Internet of Things, with enhancements, advancement in the technology. There are a lot of devices which are getting connected, and this is one big trend. Another thing is with enhancement in the computing world. There are systems which are getting developed which are good enough to handle a big amount of data. Another important aspect is virtual reality. validating your products very early in the life cycle. For that, this virtual reality technology is being used to the greater extent. AI and machine learning are changing not only the product but also the manufacturing processes in today's world. And there are three important trends as far as manufacturing is concerned. Say, for example, 3D printing, flexible manufacturing, and generative design and manufacturing practices, which are bringing a big change as far as manufacturing is concerned. Okay, a quick view on what are the opportunities specifically for automotive suppliers in today's changing automotive world. Definitely, from electrification, there are two important aspects like battery. Although a lot of innovation is happening around related to batteries, still, there is a lot of scope for suppliers to get into this particular field, and a lot of scope for design and development of battery cells and battery packs, specifically for the OEMs. Another important aspect is electric machines. That is a new aspect, whereas battery electric vehicles are concerned, and there is a huge scope for suppliers in this domain as well. But apart from that, there are existing domains which will get transformed because of the electrification. And the first domain which is directly connected is electrical. So there you will see a lot of changes into the electrical electrical components for battery electric vehicles, specifically because it's not only the auxiliary that they have to manage. Today they will have to manage high voltage high voltage current as well, specifically coming from the powertrain. Then when it comes to body, there is a lot of I would say transformation going on. Specific attention is on weight management, because weight of the vehicle will directly affect the battery range, and because of all the range anxiety around, this overall body design is adopting new ways in order to reduce the overall weight of the vehicle. And last but very important aspect is chassis. So this is another aspect. Say for example, the overall vehicle dynamics will change with introduction of batteries on the lower side of the chassis, and with very low center of gravity. There is huge scope for further development and design. Also, a lot of startups and OEMs are coming up with the electric skateboard platform, so which is going to change the chassis design going forward. So these are the few opportunities that we have highlighted, and while we work and interact with suppliers, we have seen a lot of efforts in terms of design and development of new components, new systems and subsystems for OEM from the supplier side. Okay. Also, if we talk about the government initiatives, there are a lot of incentives which have been announced by Government of India, and it's a phase-wise manufacturing program which has been already announced, which kind of deals with various components related to the electrification, including battery packs, inverters, wiring harnesses, power distribution units, and onboard chargers. And the next phase will be related to the motor, electric AC compressors, and DC-DC converter, which will be followed by manufacturing of critical components in India, which includes battery management system, battery cells, telematics, and electronic control units. And the long run components would be heat exchange, assembly, and chiller and cabin heater. So with all this, incentives and transformation happening in the complete automotive value chain, one important aspect is systems engineering. Since today's vehicle are not only mechanical, products, but they now involve multidisciplinary engineering, which includes electrical, electronics, and software as well. So with this, products are getting more and more complex, and to manage this complexity, there has to be a different approach than the traditional engineering. And this approach, which is suggested, which is recommended, is called as model-based systems engineering. So over a period of time, Dassault Systèmes has also anticipated this transformation, and in last decade, we have done a lot of acquisition to help our customers adopt this particular transformation. So the acquisitions include, say, for example, No Magic, which is a leading solution provider when it comes to model-based systems engineering. Then GeneSoft provides a requirement management application. Then Dynasim and Modelon provides physical architecture systems, which are also known as Dymola in the market. Then C-Forces, basically into the software management for AutoSAR. And then LCs, which is into electrical schematics, which is backed up by the expertise of Dassault Systèmes solution specifically for mechanical engineering. So this is the left side of the V, wherein we talk about requirements, system architecture, logical definition, and physical definition of your vehicle, right? And then we do have similar investments done on the right side, which of the V for model-based systems engineering, which includes integration, verification, and validation. So the technologies that we have, for example, we talked about the optimization of the weight of the overall vehicle. And that's where we have these two technologies, iSight and Tosca, as part of our Simulia portfolio, which kind of brings in advantage of topology and parametric optimization. And the backbone for our validation platform, Simulia, is Abacus, which is very well known in the industry today, and supports linear as well as non-linear computation capabilities. Then coming to the fluid flow simulation, we do have Xflow and PowerFlow applications, and in multi-body dynamics, SimPack, and for EMI EMC, which is another important aspect of electrification, we do have CST Studios as part of our Simulia portfolio. And we have a solution from ErgoSim, which validates your requirements very early in the stage of your vehicle development. So if you see here, there is a complete end-to-end product chain, which will help the automotive players to manage the overall vehicle development process. Also, yes, we understand that there are other solutions available in the market, and our customers needs to interact with those solutions when it comes to the vehicle development process. And that's where this 3D experience platform is open enough to adopt connections to various other applications like MATLAB, Simulink, and Modelica. One important connector is FMI, which can help you not only to exchange the data between different applications, but also it enables course simulation on the platform itself. So we will see one case study about how FMI is leveraged for doing course simulation. Also, there are various other formats when it comes to ECAD and MCAD, which are supported for your vehicle definition on 3D experience platform. And again, there are a lot of connectors available in the verification and validation world as well. One important aspect is these solutions that we develop, we also take guidance from international institutes specifically related to automotive. For example, International Council for Systems Engineering in COSE. Then we are member of Global Automotive Advisory Group, specifically MBSE working group. And also we are part of PROSTEP IBIP Smart Systems Engineering. So, we will not maybe touch upon all the topics, but we will specifically focus on system simulation specific to the vehicle systems. Okay, so these are the few systems that are highlighted here related to automotive industry. And two important things that we see here is electric machines and power electronics, for which we do have a solution called Electrified Powertrain Library, so which offers capabilities to define and simulate your entire powertrain on a virtual test bench. Another aspect of electrification is battery cells and battery packs. So we do have libraries which can help you to understand the behavior of your batteries using digital simulations. Apart from that, there are other libraries available. For example, Vehicle Dynamics Library, which can help you to do simulations related to the suspensions. Another important library is cooling of EDrive components, because this is one of the important aspects, to maintain the overall temperature of your EDrive components, including battery, right? So we do have a cooling library which kind of hosts all the mechanisms required for your cooling circuit. Then air conditioning and cabin comfort. So these are other two libraries which will ensure or help you to estimate or do the energetic dimensioning for your HVAC system. So there are many other libraries, but I've just highlighted few in regard of today's topic. So here are some details specific to the electronic powertrain library and the battery library. What are the capabilities and components that it supports? So the first one is machines. So we do have permanent magnet machines and other types of machines, models available as part of this library. How it helps is it helps in analysis of say loss behavior depending upon the machine type, then energy efficiency from electric and mechanic powers, and the thermal behavior of the electric machine. Then another component of EDrive is inverter. So you can simulate the overall behavior of the inverter, and you will be able to do the analysis of inverter switching frequency, loss estimation for thermal simulations, and aging of semiconductors. This library also provides test benches for different powertrain configuration, different energy consumption scenarios, and it also provides solution for hybrid electric vehicles or battery electric vehicles. Also, it has these test benches has got capabilities related to the overall thermal management. Also, we do have the components related to the modulation methods and electromagnetic controllers for your vehicle. Sorry, electric machine controller, which includes speed, torque, and current. Another important aspect for this electric powertrain is battery. So we do have dedicated battery libraries. Of course, this electric powertrain library has got battery components, but if you want to do a detailed analysis for your battery cells and battery pack, so there is a dedicated library available, which will help you to define the electrical model of your battery. Also, it will help you to do the thermal analysis of your battery cell and battery pack. It also has a aging model, which is an important aspect because this aging is important specific to the warranty that will be given to the customer for battery life. Also, we do have different types of battery packs, and one important aspect is parameter fitting and optimization. With the 3D Experience platform and the capabilities for optimization which are available on the platform, we'll be able to run different scenarios in order to arrive for the better optimized performance of the battery. So this is the EV development process that we will be supporting. This is how we foresee the development of electric vehicle, specifically related to electric powertrain. So it starts with requirement management, overall requirements. Say, for example, what will be the overall weight of the vehicle, what will be the overall torque requirement, what will be the overall range requirement for the vehicle. And based on that, we can do the energetic dimensioning. So for example, in order to achieve the requirements which are mentioned, like range, torque, and overall weight of the vehicle, what should be the size of my various components in electric powertrain. For example, the motor, the battery, the inverter, the DC-DC capacitor, and all other components which are required for my electric powertrain. Then we come to the one level deeper, design for specific for battery. So battery cell dimensioning, battery aging, battery cooling, and battery cycle simulation can be done as a part of cell development using these libraries. If you want more higher fidelity model, then there is there is a provision available wherein you can also model the electrochemical behavior of the battery cell. So once the battery cell dimensioning is done, analysis is done, then we come to the overall battery pack. So we do have capabilities to do overall battery pack dimensioning and battery pack cooling. Also for other components related to electric powertrain like motor, machine controller, machine modulator, inverter, DC link capacitor, and overall electric analysis for my vehicle, which will be followed by the thermal management at vehicle level. So this is the complete process that we support. That we we support simulation using 1D libraries. So what we will do now is basically we will go through some of the case studies. We have been working with a lot of customers here in India, and we have done a lot of projects for our customers, and basically this description of that, but these projects will help you to understand how these electric powertrain library and battery library can help you in your overall EV development. So the first case study is L5 electric vehicle. So it is one of the leading EV startups and charging infrastructure company in Delhi NCR, and they came to us with following scope for their vehicle. So the first one was validation of electric vehicle data, which includes energetic dimensioning. Then selecting cell chemistry based on the requirement, and followed by battery pack sizing and thermal simulation. So we also did consider regenerative braking for doing the energetic dimensioning for this particular vehicle. And one interesting scenario that this customer wanted us to do, was it's a commercial vehicle which used to, which is supposed to drop off the load at different places, and there will be a positive impact when unloading is done on overall range of that particular vehicle. So in our electric powertrain library, we had a provision that with use of some tables, we can define this unloading parameter over a given distance. And that's how we were able to calculate what would be the increase in the range of that particular vehicle with given unloading scenario. So such kind of what if scenarios you can do once the correlation is established between the vehicle performance, the physical performance, and the output of these libraries. So what solution we have used for this? Two libraries, Daimola Electrified Powertrain Library and Daimola Battery Library. So here is another case study from another customer. So this is a leading automotive tier 1 supplier, and they wanted us to help them to design their cooling system specifically for battery. So again, in order to establish correlation, we did validation of electrical vehicle data using electrified powertrain library, then cell chemistry and parameterization. So here what we do is we find out equivalent RC circuit specific to that particular battery, and those RC circuit parameters are used for doing the simulation. Once we do establish those parameters specific to the cell, then we can model by putting those cells in series and parallel to define the battery pack. So as I told earlier also, so there are various parameters that we can study for battery pack. Say, for example, state of charge, current, and voltage. But apart from that, two important parameters are thermal performance and the aging, right? So here, along with the state of charge, current, and voltage, we also did overall thermal performance for the battery cell. And here we understood that for a given drive cycle, there is a continuous increasing in the battery temperature. So what we did is in the platform itself, we do have capabilities related to cooling cycle. So we introduced this cooling library, and the heat port was connected to the battery pack, the base of the battery pack. And then we did the similar situation, simulation using this cooling circuit. And this is the performance, the thermal performance that we observed by applying the cooling circuit. So here we used electrified powertrain library, battery library, and as well as cooling library. Then another interesting case study, this is coming from electric bus startup, and they not only wanted to validate the electric vehicle data, but also they wanted us to do battery pack sizing and thermal simulation, and also they wanted HVAC and cabin comfort simulation. So with the heat load and available cabin comfort libraries and HVAC libraries in the 3D experience platform, we were able to model this particular scenario, and we were able to give the input specific to HVAC dimensioning for this particular bus. This is another interesting case, and here we have used FMI interface for doing co-simulation. Okay, so this is a customer Bangalore-based electric two-wheeler startup, Go Green, and the scope that we had received was on FEA simulation and also for the 1D simulation. So for example, the structural integrity of the battery they wanted to check. Also, they wanted to check the thermal management and battery cooling. So here what we did is we used Daimler electric powertrain and battery library in order to establish the heat generated by overall battery pack. And that input was given to FEA simulation for doing thermal simulation, thermal analysis, and that was a co-simulation that we did using FMI connector. Okay, so for that we used Daimler for electric powertrain and battery library. We used Abacus for structural and thermal and impact analysis. And PowerFlow was used in order to understand, the overall thermal management and battery cooling. So with that, we were able to suggest modification in the existing vehicle in order to have an effective cooling of the battery pack and the correct positioning of the battery pack from the thermal performance point of view. And that was kind of input, or that was the outcome of this simulation that we have achieved for this customer. So this is a case study which is also available in the public domain, which is available on YouTube, and you can have more details about it. Okay, so in summary, if you specifically talk about 1D simulation, so we do have capabilities, for simulating battery electric vehicle and hybrid electric vehicle. Also, we use an hierarchical approach for defining basic parameters through energetic dimensioning to further detailed analysis of battery, motor, and vehicle. Through the last case study, we were able to establish that 3D experience platform can help our customers to do the co-simulation and understand the behavior of the vehicle from various aspects. There are pre-built templates available which can accelerate your overall simulation process. And Daimler models are fast and easy to simulate. So with this, I end up my presentation. I hope you have enjoyed this. And if you have any further questions or any details that you need, you can reach out to us.
Write to us at marketing@edrivestechnologies.com. We'll be glad to assist all your queries, and we'll get connected soon. Thank you so very much.